Hello, my name is Rohan Sagar, and I'm a master's student at San Francisco State University. This was my project, IoT Safety Equipped Bicycle. This was done under the guidance of Professor Hamid Shanhauser, and this was partly funded by Engineering Department at San Francisco State University. So that being said, let's just move on to what we'll be talking about today. I'll be talking about my project, and especially we'll be going at why I decided to do this project, the introduction, and then followed by accident analysis of bicycles. And we'll be talking about some of the products that are currently available in the market. Then we'll move on to what is the system that I'm proposing right now, and more details about it. So since the project is about bicycles, bicycles need no introduction, but I want to talk about some of the advantages that bicycles provide. So here are some of the advantages. Bicycles are really green. In addition to that, they also help you stay fit, and their cost of maintenance is virtually zero. This is the reason why they're mostly used in cities, and their adoption is also increasing recently because of all the advantages of cycling. Right here we have the bicycle market statistics, and these statistics are in the US market. So the US bicycle market is worth $6.2 billion every year, and every year 17.4 million units of bicycles are sold. So as you can see, this market can be said as a considerable market, and this market is worth looking into when building safety devices, right? So the number of people riding bicycles have been increasing for the past 3 years. It was, as you can see in the slide, it was 43 million people riding bicycles in 2014, and that increased by around 4.5 million by the time we hit 2017. So that indicates partially that the people using bicycles are increasing every year. Now that we've talked about some of the basic introduction, let's just move on to safety of bicycles, because safety is one of the considerations when people talk about bicycles. It is associated with not so safe or being dangerous. Here's why. These are the bicycle statistics in the United States alone. It's on the x-axis, you can see the years, and the y-axis shows you the number of fatalities every year. And based on this data, which was collected from the US Department of Transport Security, they did a survey, and this data is based on that survey. It can be said that around 700 people die every year in the US alone due to bicycle accidents. Well, so I wanted to look into how and why bicycle accidents occur, but before that, I just looked into how safety is implemented in bicycles today. So as you can see, all the devices here, or all the equipment here, is what is associated to bicycle safety today. It's mostly dependent on protective gear like helmets, lights, and also reflective gear. These help you in the event of an accident, but they provide limited functionality when it comes to prevention. So that being said, I wanted to look into bicycle accidents and how they occur, just so that we can get a picture of how they can be avoided, right? So here's a couple of diagrams, and before that, let's just talk about the types of accidents on bicycles. So there's two types of accidents that bicycles are involved in, major types of accidents. First thing is called junction accidents. These accidents are what occur near a junction or in a junction. And then there's non-junction accidents, which, like the name suggests, they just occur elsewhere, not near a junction. So the diagrams that show here, that are depicted here, are they show junction accidents where it can be said that the main problem is due to the other motorists not noticing the bicycle. So these are junction accidents, but what I was interested in is more of non-junction accidents because I felt like this is where I could apply some of computer science concepts to help improve the safety. So as data suggests, 58% of all accidents, all fatalities in 2016 were caused due to non-junction accidents, right? So when I say non-junction accidents, it's basically two types of accidents. The first one being overtaking crashes, which is when a car hits a bicycle trying to overtake it, as shown in the diagram over there, and a rear end crash, which is where a car crashes into the rear end of the bicycle because they didn't know it was there, or they just didn't notice it soon enough. So these are the two types of junction accidents, and looking at these, I wanted to analyze them because I felt like this is one of the areas where I can actually apply devices to provide safety. So I looked at them more closely, and I did some research based on why these accidents occur. And research suggests that rear-end collisions are usually occur due to low visibility of the bike, and overtaking collisions occur due to the difference in speed of the car and the bicycle, because it's not the same for a car when it's overtaking another car versus a bicycle because of the speed difference. And that is what research suggests is the main cause of overtaking accidents. And on the rightmost column, this is my solution of providing security and safety for the bicycle in this scenario. So I'm trying to avoid rear-end collisions by making the bicycle more conspicuous by using lighting systems. And my solution to overtaking collisions is to help the bicycle maintain more speed, and also in part the lighting system also helps, but mainly helping the bicycle see what's happening and maybe speed up, or in general maintain more speed in that lane. So based upon this, I built my project to provide these features. We'll talk about that in a bit, but before that, I'd like to talk about some of the products that are available in the market today. So the picture over there talks about, like, it's an example of how many devices that are in the market today. So I felt that by looking into the products already available, we can draw some inspiration and learn from the flaws that we see from those products. So today, as the market stands, the devices in the market can be broadly classified into three different types, right? So first one being fitness-oriented products, which are mainly geared towards performance bicycles as they measure fitness data. And the second one being lighting systems. They provide, as the name states, lighting for the bicycle. And the third one being specialty, you can say. It's stated as other safety related products, but they're more of, they don't fit in like both of the above categories. So these are like specialty items. So let's look into each of those. Fitness oriented products. So as you can see here, this is Garmin's take on safety add-ons. So Garmin, as the name states, they usually make stuff for fitness enthusiasts because they're more fitness oriented. But their safety add-on is a light that is shown here. It's called Varia radar taillight for the. It works in conjunction with the bike computer up there. to measure the distance of the vehicle that is behind the bicycle, and it also alerts the rider if the vehicle is coming close. And this is one of the safety add-on of Garmin, but some can argue that Garmin's products are expensive and they're not made for safety, they're made for fitness enthusiasts. That being said, let's move on to lighting systems. As the name states, they provide lighting. Here are different products that provide lighting. Helios bars, these are light up bars. Revo lights light up tires based on accelerometers, and light up jackets and turn signal gloves that help you signal to the vehicle that you're turning. These are all really good in terms of like lighting and making the bicycle more visible, but lighting systems alone cannot provide all-around safety. One can say that there's more to be desired in this department. So that being said, lighting systems are a good idea, but there's more to be desired out of like a system that is all-around. So let's talk about other products. So these cameras right here are a combination of a camera and a light. They're called, they're from Cyclic, the company, and Fly 12V and Fly 6V are cameras. These products are provide a little different feature set. They allow you to record your ride in terms of like the road and what you were doing, so that if there's an accident, you can use the data to analyze the accident or for any post-processing. So that is what they are. They also double up as lights, but their main feature is video recording for like dash cam purposes or reviewing later. And this is a navigation tool which lights up based on your set location where you have to go. It's a hammerhead navigation system on the right there, bottom. So now we've just looked at all of the, most of the products that are available in the market today. So based on all these, I was able to analyze most of them based on their safety features, and after doing that, I determined that desirable qualities in a system are the ones that are stated here. So lighting system is one of the big ones. So lighting system is really important for a bicycle. In addition, if the system can provide a better view for the rider, that's a good one too. And then it can provide like additional safety using video recording. I felt that this is one of the features that is a good idea. So I went ahead to implement these features in my implementation of a safety device. And since there is a lack of all-in-one safety device, I wanted to build one that is all-around, that addresses all the problems of safety in bicycles. Now I'm going to be talking about the system that I built, which consists of 3 modules. The first one being smart mirror module, which provides a smart mirror functionality using a camera and a smartphone screen. And there's also a rear lighting module followed by an electric module. So rear lighting module provides lighting, electric assist module helps the rider stay and maintain speed or get to speed by providing pedal assist. So this is the block diagram of my project. We will be talking in detail about each and every module in the coming slides. But for now, as you can see, there's a camera and a Raspberry Pi streaming the video to a smartphone. This constitutes of the smart mirror module. And the rear lighting module consists of a display and buttons to trigger lights. And the electric assist module provides propulsion to the bicycle. So by propulsion, I mean pedal assist by using the hub motor that's mounted. And so the main feature of this module is this project is that it's modular, and the rider or the customer can pick and choose what they want and leave out the things that they don't need, so that it forms a modular design for safety approach. So let's talk about smart mirror module. So the smart mirror module, what it essentially does is it takes the video from the camera and then it streams it to a web server. This web server is implemented on a private network that is created by the Raspberry Pi itself. As you can see, the box over there has batteries and then Raspberry Pi and a camera. So the Raspberry Pi is trying to create a network, a private network to which the camera stream is sent to, and that can be accessed by any other smartphone. This module uses, as I said, Raspberry Pi, a Pi camera, Raspberry Pi 3 Plus because it's got 5 gigahertz capabilities for the Wi-Fi. Pi camera, specifically that one because it's got the CSI interface, and which feeds the video directly into the GPU of the Raspberry Pi, which helps with the latency and the speed of retrieval of data from the camera. So in addition, there's also a battery management system for powering it, and then there's storage. That being said, let's move on to rear lighting module. So once we're done with the basic hardware of the modules, we'll be talking more about software and how it's implemented. So the rear lighting module consists of 4 8x8 LED matrices put together horizontally to form a display. So what this does is it flashes to let the vehicle behind the bicycle know that of the existence of the bicycle. And there's 2 buttons on the side which can be used to trigger a turn signal response. So if you're turning right, you just hit the button and then it flashes to the right, indicating to the vehicle behind it that the bicycle is going to take a right. And it also has a rechargeable battery. It is rechargeable, it's got LiPo battery, and this is implemented using a TIVA-C microcontroller, which is a microcontroller from Texas Instruments. It has an ARM Cortex M4 microprocessor in it, and the dot matrix display is, as you can see there, and battery and a battery management system. So it provides lighting by using all of these components, and it can be rechargeable. So now let's talk about the electric assist module. So the electric assist module, it provides pedal assist for the bicycle, and in doing so, it helps in avoiding overtaking collisions. So it's got a motor, it's got a battery, and it's got a controller, just like any other electric system. So the picture right here shows the hub motor that is rear mounted so that it can drive the bicycle. And here's the control circuitry. It's not circuitry, but I'd say control module, which is responsible for the throttle and then braking and the PWM signals that are required for running the running the hub motor. And here is the battery. So the battery is mounted on the down tube of the bicycle, and it can be locked or unlocked and removed from the bicycle for charging. To put together, we've got 3 modules. The smart mirror module, which uses Raspberry Pi to implement streaming, and the lighting module, which provides lighting, and electric assist module, which helps the rider in propelling the bike, thus making it easier and a little safer. Now that we've finished all the hardware components, let's just move into software. And here are all the components of software. So which is, most of the software is in smart mirror module. So, but there's still a little bit of software in the rear lighting module as well. So we'll be talking about how we implemented a Wi-Fi access point, and then a web server, and how are we implementing streaming and video recording, and at the end we'll talk about some of the programming that was involved in the lighting unit. So Wi-Fi access point. So in order to create a network using Raspberry Pi's onboard Wi-Fi chip, we will be using a couple of different applications for Linux, which are host APD to create an access point. And by creating an access point, we also need to take care of the IP addressing and the low-level network protocols. So for that, we'll be using a DHCP server, so that when a device connects to the network, it is assigned an IP address. So we do this by implementing a DHCP server, which is achieved by using DNS mask. So these are the two applications that we're using for our implementing of the access point, which is host APD and DNS mask. And then again, the web server. So once the access point is created, we need to create a web server which streams data, the camera data that we get from the camera. So this is implemented using using Python script with HTTP server module, and it runs on port 8000, and any smartphone can be connected to it because it's just a web page that's streaming. So for streaming, we're using MJPEG Stream because it was observed to be least stuttery and really fast in terms of like when it comes to streaming. And it uses Python spy camera module to get the stream and then get the video data and then stream it to the web page. So here the resolution that we're using right now is 640 by 360 and at a frame rate of 40 frames per second. But this is chosen to have more video archival duration. But if this can be changed to a higher frame rate or lower frame rate or higher resolution based on the storage needs and how much time you want to store the data. So it's adjustable. So video recording, we're using multi-threading to record the video while streaming the video. So one Python script is recording the video while the other one is streaming, and the recording is done in a circular buffer sort of fashion where the first file that is recorded is overwritten by the time we hit the end of the 10 files, let's just say. So it's just constantly being overwritten and stored on a location in the SD card on the Raspberry Pi. Now, the software for the lighting system is implemented in C. So since the LED matrix display uses SSI communication, we're using the we're using the TIVA C to communicate with the LED matrix using SSI, and the turn signals are driven with interrupts. So when you press the button, it hits an interrupt, and then it goes into another mode and then comes back, and all the updating is done with SSI. So finally, I'd like to talk about what we achieved with each of these modules. So results. Smart Mirror module is capable of streaming the video of the back of the bicycle to the phone mounted on the front, so that you can see it as a mirror with virtually no delay, and it can also record 12 hours. Right now, it is set to record 12 hours of the 640 by 340, or if my memory serves right, 40 FPS video to the SD card, which is also reprogrammable to the user's needs. And the lighting module is capable of running for 12 hours and it's capable of displaying stop and turn lights. And the electric assist module is capable of propelling the bicycle without any effort from the rider. If the rider chooses to, he can add in more power by pedaling. And the top speed is around 20 miles per hour or 40 kilometers per hour. And in our testing, the range was around 15 to 20 miles. That being said, let's conclude by just wrapping up all the stuff that I did today. So we examined the need for bicycle safety and then how bicycle accidents occur. Based on that, I was able to draw how to solve some of the problems, and I implemented a smart mirror module to give a better view of the surrounding areas to the rider. In addition, I implemented a lighting system that can provide lighting to the bicycle in dark conditions or maybe in day to make it more visible to the other riders. And I also implemented an electric assist module that can propel the bike and thus helping with overtaking accidents and also improving the ride experience for people that are not so fit. Here are my references. For this, I looked into a lot of bicycle research, bicycle accident analysis, and in addition, I also looked into the statistics that are from the U.S. Department of Transportation, and I also looked into some of other people's take on how to use IoT to build a safer bicycle, that's all for now. And thank you for being so patient, and that'll be all.